Welcome students. This is our second lecture on complex geometry. I will request all of you, those who have not seen my previous video on complex geometry, I do suggest everyone to see that video first. The link has been given in the description, so please check it and then you come and see this video because that will be helpful for you. Okay, so in this lecture we will mainly concentrate on the straight lines. Straight lines on a complex plane. Okay, now you see in the Cartesian system we know that the general equation of any straight line is ax plus by plus c equals to 0. Okay, where x and y is a variable point on that Cartesian plane. That is, x and y is a variable point on that line itself. Okay. Now, in the complex plane, the variable point we generally denote it by z. The coordinate which is associated with this complex number is x comma y. That is, this complex number is nothing but x plus iota y. So, the conjugate of this complex number will be x minus iota y. Is it clear? Now, what is your x? X is basically z plus z bar by 2 and your y is nothing but z minus z bar by 2 iota. Is it clear? Now, if I plug these two values of x and y in this equation, that is in the Cartesian form, so we will be, this Cartesian form of the straight line will be converted into the equation of a straight line on a complex plane. Let me just substitute, let me just plug the values of x and y over here. So we are having tell me yes or no. So in this case we can do, let me just simplify a little bit. So we are having basically let me multiply with iota numerator and denominator. So in the denominator we will be having 2 iota square and c is as it is. So this will be converted into iota square is minus 1, so minus will come out. Is it okay with all of you? Now let me just simplify a little bit. Fine. Now let me just denote this complex number with alpha. So this will be the conjugate of this complex number alpha. So this one is nothing but your alpha bar. Is it okay? Therefore, the equation of the straight line on the complex plane becomes is it fine with all of you? This is what is termed as the general equation of a straight line on a complex plane. That is alpha bar z plus alpha z bar plus c equals to 0. Now, the main thing, how we will understand if I give you any equation, whether you will understand, how you will understand that that equation represents a straight line on a complex plane. First thing that you must see is, here it is z bar. Okay. So, whatever coefficient, whatever complex number, because here alpha is a complex number and c is a real number. Let me write it here. Alpha belongs to any complex number and c belongs to any real number. Don't confuse this c with this c. Okay. This c is this one and this is for the complex number. Let me write it. Otherwise you will be confused. Okay. So, the complex number that is associated with z bar and the complex number associated with z will be always conjugate to each other. This is the first criteria. Number one. Number two is, you have to see that there is a plus sign in between. Okay? And this constant C is purely real. You must remember this. It's a very important point. So two things that you must see, that this alpha and alpha bar, which are the coefficients of Z bar and Z respectively, they must be conjugate to each other. There must be a plus sign in between, and the constant term C must be purely real. Is it clear? In that case, we will say that this represents the equation of a straight line on a complex plane. Okay? Now, let me write the same equation in another form. Please look at it carefully. We are having right? Now, if I multiply with iota all the sides, so what we are going to have? Is it clear? Now, let me just open the brackets. So we are having please check it whether I'm correct or not. So in this case, you observe, if I term this thing as my alpha, if alpha is b by 2 minus a iota by 2, then this one is the conjugate of this complex number. So this one will be your alpha bar, which is b by 2 plus a iota by 2. So in that case, the equation of the line becomes alpha bar z minus alpha z bar plus iota c equals to 0. Now again, this also represents the equation of a straight line on a complex plane. But remember few words, few things over here. That is, here alpha and alpha bar, again they are conjugate to each other. That is, the coefficient of z bar and the coefficient of z, those complex numbers are conjugate to each other. Number one, that's okay. That is same, that was same with the previous one also. But here you observe that there is a minus sign in between. If there is a minus sign in between and the last term is coming to purely imaginary, then also we will say that this represents equation of a straight line on a complex plane. Remember two things. One is, if there is a plus sign, first criteria is that the coefficient of z bar and z, the complex numbers, they will be conjugate to each other. This is the number one thing. And number two, if you find that there is a plus sign in between, then this constant will be purely real. And if you find that there is a minus sign in between, because these two complex numbers are conjugate to each other, these are true for both these cases. So if you find that there is a minus sign in between, then the constant term must be purely imaginary. In these two cases, we will say that this represents a straight line on a complex plane. Is it clear or not? So let me just write these two things in this page. First thing that we have learned is that alpha z bar plus alpha bar z plus c equals to 0. This represents a straight line on the complex plane. How to remember? First of all, we have to see that the coefficient of z and z bar, which are the complex numbers, and they are conjugate to each other. This is number one. Number two is that there will be a plus in between, and this constant is purely real. That was the first case. And the second case that we have done is that again these two complex numbers are conjugate to each other, but there is a minus sign in between. If there is a minus sign, then this constant term will be purely imaginary. In that case, we will say that this two represents straight lines on an Argand plane or a complex plane. Now suppose, let me take an example like 1 plus iota z bar plus 1 minus iota say z, and this is say plus 3 iota is 0. Now my question is, does it represent a straight line on the complex plane? First of all, we have to check that this one is what? This is the complex conjugate of this. This complex number is the conjugate of this complex number. So the first condition satisfies. Second one is there is a plus in between. Since there is a plus in between, so this one must be purely real, which is not in this case. Therefore, this does not represent a straight line on the complex plane straight away. Suppose we have been given 1 plus iota, the same sum I am taking, with a minus sign over here. But here it is say 3 equals to 0. Now again, does it represent the equation of a straight line on a complex plane? Look it carefully. This one and this one, they are the complex conjugate of each other. There is a minus sign in between. If there is a minus sign, then this constant term must be purely imaginary, not purely real. In this case, it is purely real. So this does not represent any straight line on the complex plane. Now let me take another example, like say 3z bar plus 3z plus 7 equals to 0. Does it represent a straight line on a complex plane? Let us check. First thing, we have to check that whether this one and this one are complex conjugate to each other or not. This one, if I treat this thing as my alpha bar, is 3. 3 means what? It's iota into 0, right? So what will be alpha? Iota will be replaced by minus iota, which again gives you 3. So this I can say the complex conjugate of this one. So the first condition satisfies. Second one is there is a plus sign in between. If there is a plus sign in between, then this has to be purely real, and which is purely real in this case. Therefore, this represents a straight line on the complex plane. That's for sure. Is it clear? So these two things you must remember in this case. Now in the Cartesian form of a straight line, we know that ax plus by plus c equals to 0. We have derived those equations from this Cartesian form itself. So what is the slope of this line? The slope of this line will be minus a by b. Yes. Now can you please remember what is your alpha that we have assumed? Let me just turn the page. Your alpha was a by 2 plus iota b by 2. And alpha bar was a by 2 minus iota b by 2. Let me write it here. So alpha was a by 2 plus iota b by 2 and alpha bar was a by 2 minus iota b by 2. Correct? Now if I add these two, so we are going to have a, and if I subtract these two, you are going to have 2 iota b. That implies b is nothing but alpha minus alpha bar by 2 iota. Is it clear? Am I correct or not? No, I'm sorry. This 2 will be not there because b by 2 plus b by 2 will give you only b, right? So no 2 will come here. Okay. So b is alpha minus alpha bar by iota. So let me just replace it here. So what is the slope of the line in this case? Minus this a. Let me just replace it by alpha plus alpha bar. And in the denominator we are having alpha minus alpha bar by iota. This iota will go up. So it will be something like this, alpha plus alpha bar by alpha minus alpha bar iota. Okay. Let me take a minus common. So alpha bar plus alpha by alpha bar minus alpha into iota. This is what? This is the slope of the line. Slope of the line. Okay. In the Cartesian form, I have simply replaced it by the complex numbers that we have assumed. Now, this one, this m, in complex plane, we term this thing as angular coefficient of the line. This is the angular coefficient of the line. Line, which line? This line. This is the angular coefficient of the line. So the angular coefficient of the line represents the slope of the line ax plus by plus c equals to 0. Is it clear? Now, this is the slope for the Cartesian form. Suppose we have been given the equation of the line in the complex plane, let us say this: alpha bar z plus alpha z bar plus c equals to 0. Then what will be the slope of this line on the complex plane? This slope is what called your complex angular coefficient. Complex angular coefficient of the line. So this line is A. So of the line A on the complex plane. Is it clear? So the complex angular coefficient, which is termed as the slope of this line A on the complex plane, and which is nothing but the ratio of alpha by alpha bar with a minus sign. You have to remember this. So this is the slope of a line on a complex plane, which is of the form alpha bar z plus alpha z bar plus c equals to 0. Is it clear? Now a question naturally arises, sir, if the form is in this, if the form is, say, this one, which is our second form, right? In that case, what will be the slope of that line? In that case, your slope of the line will be, the complex slope of the line will be alpha by alpha bar only. Now, a natural question comes, how to remember this slope in an easier way? See, for a time being, you people all remember in this way that this one, this z is y and this z bar is x. Let us say, we know that in the Cartesian form, a plus by plus c equals to 0, ax plus by plus c equals to 0. In that case, your by was ax minus c, so y is minus a by b, x minus c by b, right? And this was the slope. This was the slope. How we are getting? We are getting it like minus a by b. A is what? It is the coefficient of x. And b is what? It is the coefficient of y. Apply the same thing over here. The coefficient of x is alpha. The coefficient of y is alpha bar. Therefore, the slope will be minus alpha by alpha bar. Is it clear or not? Is it clear or not? Absolutely. Okay. Same thing. Try it here. This alpha bar, we will treat it as x, and this, z bar will be treated as x and z will be treated as y. So in that case, your slope will be alpha by alpha bar. No minus sign will be there. Is it clear to all of you? So this actually represents the complex slope of the line alpha bar z plus alpha z bar plus c equals to 0. The complex slope will be this, and the complex slope will be this for this form. Is this okay? Suppose I'm considering two straight lines. This is the equation of two straight lines on the Argand plane. Now, the slope, the angular coefficient of this line will be what? It will be alpha bar plus alpha by alpha bar minus alpha into iota. This is actually the slope of the straight line in the Cartesian form. This is the slope m1. And what is the slope m2? This will be beta bar plus beta divided by beta bar minus beta iota, and that is your slope m2. Now, if these two straight lines are parallel to each other, then what you will write? You will write that these slopes will be equal if they are parallel. Okay? That is iota equals to beta bar plus beta by beta bar minus beta iota. Is it clear? When two lines are parallel to each other, right? So I goes off. Let me just cross multiply. Let me just open the brackets. Simple multiplication. Nothing complexity is there. Is it fine? Now this goes off. Alpha bar, beta bar goes off, right? So what we are having basically 2 alpha beta bar equals to 2 times alpha bar beta, right? So from here we can get 2 goes off again. So it's alpha by alpha bar equals to beta by beta bar. Okay. So you can write in this way also, minus alpha by alpha bar equals to minus beta by beta bar. Now this is what? This is basically the complex slope of the line alpha bar z plus alpha z bar plus c equals to 0. Yes or no? Yes or no? So let me denote the complex slope of the first line as mu1 and the complex slope of the second line be mu2. So we can write that mu1 here is nothing but mu2. Is it clear or not? So what we have learned that when 2 straight lines are parallel to each other, then their complex slopes will be equal. Okay, now let us say that these 2 lines are perpendicular to each other. Perpendicular to each other means what? M1 into M2 will be equals to minus 1. That is into that is minus 1. Iota into iota is iota square. So that gives us minus 1. Minus 1 minus 1 goes off. So we are left with equals to. Now let me simply multiply. It is simply multiplication. Look it carefully. Okay. Now this goes off. What else? This goes off, right? So we are having basically 2 times alpha beta bar plus alpha bar beta equals to 0. So from here we can write easily that alpha beta bar plus alpha bar beta equals to 0. Now let me divide both sides by alpha bar beta bar. So what we are having? Alpha by alpha bar plus beta by beta bar is equals to 0. Okay. So from here also you can write minus of alpha by alpha bar minus of beta by beta bar is equals to 0. That implies mu1 plus mu2 equals to 0. Yes or no? So these 2 are very, very important deductions. That is, when you find that 2 straight lines on the complex plane are parallel to each other, you will say that their complex slopes are equal. What is complex slope? Complex slope is nothing but minus alpha by alpha bar for which equation? For the form alpha bar z plus alpha z bar plus c equals to 0. So in that case the slopes will be equal when they are parallel, and when the 2 lines are perpendicular to each other on the complex plane, then we will say that the sum of their slopes is equals to 0. Is it fine with you? Now let us say there are 2 points on the complex plane associated. These are the points, say A and B, associated with the complex numbers, say Z1 and Z2. Okay. Now the question is, what will be the complex slope of this line? What will be the complex slope of this line? That's the question. We know that equation of any line on a complex plane can be written as alpha bar z plus alpha z bar plus c equals to 0. Okay. Now observe one thing, that this line, let us say the equation of this line is this. So z1 must satisfy this equation because z1 lies on this line, as well as z2 must satisfy this equation because z2 also lies on this line. Okay. Therefore we can write alpha bar z1 plus alpha z1 bar plus c is 0, as well as alpha bar z2 plus alpha z2 bar plus c equals to 0. Am I correct? Now if I subtract these 2 equations, what we are going to have? Alpha bar z1 minus z2 plus alpha z1 bar minus z2 bar equals to 0. Correct? So we are having what? So from here we can write minus alpha by alpha bar is nothing but z1 minus z2 divided by z1 bar minus z2 bar. Tell me yes or no. Tell me yes or no. Now, what is minus alpha by alpha bar? That is nothing but the slope of this line. That is the slope of this line. That is the slope of the line joining the points z1 and z2 is nothing but z1 minus z2 divided by z1 bar minus z2 bar. This is a very, very important point to be remembered. That is, whenever two complex numbers are given on a complex plane, the slope, that is the complex slope of that line joining those 2 points, will be z1 minus z2 by z1 bar minus z2 bar. Is it clear? So far we have learned 3 very important points. That is, first we have defined what is the complex slope of a line, which is defined as minus alpha by alpha bar of the line alpha bar z plus alpha z bar plus c equals to 0. Okay, this is the complex slope of that line. And we have learned that if two lines are perpendicular to each other, then the sum of their slopes will be equals to 0. And if they are parallel to each other, then their slopes will be equal. And the third one that we have learned, very important thing, that is, if I know 2 points on the complex plane, so we can find out the slope of the line joining those 2 points z1 and z2. And what is that? z1 minus z2 divided by z1 bar minus z2 bar. Is it okay? Now suppose we have been given, let us say, alpha bar z plus alpha z bar plus c equals to 0. Now if I ask you, what is the line on the complex plane which will be parallel to this line? Now we know that what is the complex slope of this line? It is very much minus alpha by alpha bar. Now any line which is any line which is parallel to this line will have the same complex slope. Therefore, the equation of the line will be alpha bar z plus alpha z bar plus some other constant lambda equals to 0. So this is the equation of the line on the complex plane which is parallel to this line. Is it clear? Now let us come to another point. Let us say there is a line joining these 2 points as z1 and z2. And there is another line which is passing through the point z3 and perpendicular to the line joining z1 and z2. Now we have to find out the equation of this line. Simple. So how to do that? See, what is the complex slope of this line joining z1 and z2? It is nothing but z1 minus z2 divided by z1 bar minus z2 bar. Just now we have done. So the slope of the complex slope of this line is nothing but this. Now, let us say z be any point on this line. Therefore, what is the slope of this line joining the points as z and z3? It will be nothing but z minus z3 divided by z bar minus z3 bar. Okay, since they are perpendicular to each other, so what you will write? You will simply give a plus sign and that will be equals to 0. Because we know that when two lines are perpendicular to each other, the sum of their complex slopes is always equals to 0. So that way we can apply the complex slope to find out the equation of any line parallel to some line on the complex plane or perpendicular to some line on the complex plane. Is it fine with you? This form is also called non-parametric form of the line because there is no parameter. But this form is what called your parametric form of the line because there is a parameter lambda. Is it clear? Suppose we have been given a line whose equation is, this is the general equation of a line on a complex plane, and there is a point, say z0, outside this line. Now, two things we will do here. First, we will draw a perpendicular from this point on this line. We will find out the foot of the perpendicular and this distance, right? Now, let us assume that this point be Z. As Z is lying on this line, hence it must satisfy, that is, this equation is true for Z. What is the complex slope of this line? The complex slope of this line is Z minus Z0 divided by Z bar minus Z0 bar. This we all know. When we know 2 points, we know how to find out the complex slope of this line. That's exactly what we have done. And what is the complex slope of this line? It is nothing but minus alpha by alpha bar. Am I correct? Absolutely. Okay. Now you see this line and this line, they are perpendicular to each other. We know that when two lines are perpendicular to each other, then the sum of their complex slopes is always equals to 0. So from here what we can write? Alpha bar Z minus Z0 equals to alpha times Z bar minus Z0 bar. Am I correct? Now, from here, I want to find out what is my Z bar. So for that, what I'm doing? This is nothing but your Z bar minus Z0 bar. So Z bar gives you what? Z0 bar plus alpha bar by alpha into Z minus Z0. Okay? Now simply replace the value of Z bar in this equation. So we get alpha bar Z plus alpha Z bar, which is Z0 bar plus alpha bar by alpha Z minus Z0, which is plus C, which is equals to 0. Is it clear? So after simplification we are getting Is it okay? Our prime motto is to find out Z, because Z is nothing but the foot of the perpendicular. So if I open the brackets, so from here we get Z is nothing but right, and this is the position vector of the point Z, or else you can say this is the complex number which is associated with this point. Okay, so we got the foot of the perpendicular. Now the task which is remaining is to find out this length. So this length can be written as mod of Z minus Z0. The distance between 2 points is nothing but mod of Z minus Z0. Okay, so this can be written as 2 alpha bar minus Z0. So if I take the LCM, with a mod sign, so we are having alpha bar Z0 minus 2 alpha bar Z0, so that gives you minus alpha bar Z0 minus Z0 bar alpha minus C divided by 2 alpha bar. So again I can take a minus outside because there is a mod sign, so minus will vanish. So alpha bar Z0 plus Z0 bar alpha plus C divided by 2 alpha bar, which can also be written as mod of alpha bar Z0 plus Z0 bar alpha plus C divided by 2 of mod alpha bar, which can also be written as 2 of mod alpha, because we know that mod of alpha and mod of alpha bar, they are same. Therefore, the perpendicular distance from the point Z0 on the line alpha bar Z plus alpha Z bar plus C equals to 0 is nothing but this thing. Now it is pretty easy to remember. actually you see this is the expression of the straight line. The straight line is this, isn't it? The equation of the straight line is this. So if we take this expression only, and in place of z, if we put z0, we are getting the expression which is in the numerator. Okay? So that way we can remember this. And in the denominator we will have 2 times mod of alpha. Wrongly, if you take alpha bar, it doesn't matter because mod of alpha and mod of alpha bar, they are same. So we have to remember this as a formula, that this is the perpendicular distance drawn from a point z0 on a line alpha bar z plus alpha z bar plus c equals to 0. Is it clear? Okay. Now, let me take a triangle in the Cartesian plane, and the respective coordinates are A x1 y1, B x2 y2, and C x3 y3. Okay, this is on the Cartesian plane. Now, what will be the area of this triangle? The area of the triangle will be half in a determinant form. Is it clear? Now let us shift these points on a complex plane. On a complex plane, let us say that the complex number associated with A is say Z1, with B is say Z2, and with C, let us say Z3. So therefore we can say that Z1 is nothing but x1 plus iota y1, Z2 is x2 plus iota y2, and Z3 is x3 plus iota y2. Tell me yes or no. What we can write here? Half. What is x1? x1 is nothing but Z1 plus Z1 bar divided by 2. Yes or no? x1 will be nothing but Z1 plus Z1 bar by 2. Similarly, x2 will be what? Z2 plus Z2 bar by 2. And x3 will be Z3 plus Z3 bar by 2. Am I correct? What about y1? y1 can be written as Z1 minus Z1 bar divided by 2 iota. Similarly, Z2 minus Z2 bar by 2 iota. And Z3 minus Z3 bar by 2 iota. Am I correct? 1, 1, 1. Is it okay? Now what we are trying to do here is we are trying to find out the area of the triangle ABC on a complex plane associated with the complex numbers Z1, Z2 and Z3, which are the 3 vertices of the triangle ABC, right? So from here, if I take 1 by 2 iota common, so we are left with, outside it will be 1 by 4 iota, and inside we are having Z1 plus Z1 bar, Z1 minus Z1 bar 1, Z2 plus Z2 bar, Z2 minus Z2 bar 1, and Z3 plus Z3 bar, Z3 minus Z3 bar 1. Is it clear? Absolutely. Okay. Now what I am doing, I am applying column 1 dash is column 1 plus column 2. So what we are having? Del becomes what? 1 by 4 iota. Column 1 is column 1 plus column 2. So we are having 2Z1, 2Z2, 2Z3. This is Z1 minus Z1 bar, Z2 minus Z2 bar, Z3 minus Z3 bar, then 1, 1, 1. Is it clear? Now if I take this 2 outside and if we apply, actually first let me take 2 outside. So it will be 1 by 2 iota. So Z1, Z2, Z3 is there. Z1 minus Z1 bar, Z2 minus Z2 bar, Z3 minus Z3 bar, then again 1, 1, 1. Okay. Now what we are doing is basically we are operating like column 2 dash is column 2 minus column 1. So what we are having? It's 1 by 2 iota, Z1, Z2, Z3. I'm subtracting column 2 minus column 1. Okay. So what we are having? Minus Z1 bar, minus Z2 bar, minus Z3 bar. Then again 1, 1, 1. Okay. Let me take a minus outside. So it will be minus 1 by 2 iota, Z1, Z2, Z3, Z1 bar, Z2 bar, Z3 bar, then again 1, 1, 1. We have done one mistake over here because here I have only taken 2 iota common, right? So actually there is a 2 over there. Okay. So after that I am taking that 2 common. So this 1 by 2 common. So this 2 will go out and it will become 1 by 8 iota, right? A little mistake I have done. So if I take 2 common from this one, so we are left with 4 iota over here. So again, this is 4 iota. This is 4 iota. Is it okay now? So what I'm doing here is I am multiplying numerator and denominator with iota. So this thing will become minus iota by 4 iota square. Z1, Z1 bar 1, Z2, Z2 bar 1, Z3, Z3 bar 1. Okay. Iota square is minus 1. So this one will give you what? This is iota by 4, Z1, Z1 bar 1, Z2, Z2 bar 1 and Z3, Z3 bar 1. Okay. So this is the area of the triangle ABC whose 3 vertices are Z1, Z2 and Z3. Is it okay? It is better if we can remember this, right? Now, can we simplify this result a little bit? Let us try. The area of the triangle that we got right now is iota by 4, Z1, Z1 bar 1, Z2, Z2 bar 1, Z3, Z3 bar 1. Now, it has of great significance. It can be used in different ways to get different conditions for different questions. Say for an example, if I say that prove that Z1, Z2, Z3, these 3 points are collinear. So in that case, what we will do, we will simply say that Z1, Z1 bar 1, Z2, Z2 bar 1 and Z3, Z3 bar 1, this determinant will be equals to 0 because the triangle formed by these 3 points on the complex plane will be 0. So obviously this is equals to 0. Iota by 4 cannot be equals to 0. Hence this is equals to 0 implies this. So whenever we prove that this determinant is equals to 0, we will say that these 3 points are collinear. As simple as that. Similarly, if I say that find out the equation of a straight line which is passing through 2 given points as Z1 and Z2. Okay. Find out the equation of this straight line which is passing through Z1 and Z2. What we will say? We will say let Z be any point on this line. Now the triangle formed by these 3 points will be, the area of the triangle formed will be ZZ bar 1, Z1, Z1 bar 1 and Z2, Z2 bar 1. This is equals to 0. And this exactly is the equation of a line on a complex plane passing through 2 given points Z1 and Z2. Is it clear? So that is why I told you the area of the triangle, it has a very important significance in complex geometry. Okay. Now what I told you that let me try to simplify this area of the triangle. Let us see whether we can simplify this thing or not a little bit. So iota by 4 is there. So if I just open this one, we are going to have, I'm simply expanding this determinant. I'm expanding it with respect to the first row. Is it fine? Now, is it clear? So I can write this thing in this way also, iota by 4 Are you surprised why I have written in this way? No, don't get surprised. Simply a bar is there. Yes? So this means this. We can easily understand that because Z1 plus Z2 whole bar is same as your Z1 bar plus Z2 bar. That's exactly the same conception I've used here. Moreover, Z1 bar, then again bar will give you Z1, right? So now you observe, for this complex number, this is same as this, yes or no? Because here Z1, let me write it in a systematic way so that you can understand better. Plus a Z2, Z3 bar plus Z3, Z1 bar. It looks better, isn't it? And let me write it here, the same thing. Z1, Z2 bar, Z2, Z3 bar plus Z3, Z1 bar, whole bar. Okay? Now, if this is the complex number Z, let us say, then this is what? It is simply Z bar. Now, can you please tell me what is Z minus Z bar? This is simply nothing but 2 iota imaginary part of Z. So, from here we can write this is equals to iota by 4, 2 iota imaginary part of Z. In this case, the Z is Z1, Z2 bar plus Z2, Z3 bar plus Z3, Z1 bar. Tell me yes or no. So this gives us what? It is basically coming to minus half imaginary part of Z1, Z2 bar plus Z2, Z3 bar plus Z3, Z1 bar. Okay? This looks much better. Okay? See one thing. Suppose Z is X plus iota Y. So Z bar will be what? X minus iota Y. So imaginary part of Z is basically Y and imaginary part of Z bar is basically minus Y. Yes or no? So can we write this thing in this way? It is simply as half imaginary part of Z1, Z2 bar, the whole thing with a complete bar. Yes or no? Because then this minus sign which was outside will be vanished. So again, this can be written as what? Z1 bar Z2, Z2 bar Z3, Z3 bar Z1. Okay? This is much better way of looking the area of the triangle on a complex plane. So it is also advisable to remember this form also. Pretty easy to remember because you will simply remember half, because in the area of the triangle, even in the Cartesian form, we have a half outside every time. So half is there and the imaginary part of this is a cyclic one. Z1 bar Z2 plus Z2 bar Z3 plus Z3 bar Z1. Okay, so that is the area of the triangle with vertices Z1, Z2, Z3 on a complex plane. Is it okay?
That's all for this video. In the next video, we are going to solve problems based on whatever we have learned in this lecture. So till then, goodbye and take care.